Hello guys, I am back with my second video that I've decided to release 5 minutes after my latest one. And we are back with a related rates problem. So let's read the problem together. A man starts walking north at 4 feet per second from a point P. 5 minutes later, a woman starts walking south at 5 feet per second from a point 500 feet due east of P. At what rate are the people moving apart 15 minutes after the woman starts walking? So first, let's draw what this looks like. So we have a man at a point P, and he's walking north at 4 feet per second. And over here we have a feet. Wait, what? We have a feet. We have a point 500 feet due east of P. So let me make sure I get this right. Never ever smoke weed. Okay, so here we have P prime. Let's call it P prime. And we have a woman that is walking this way at 5 feet per second. And this is 500 feet due east. So, what do we do now? So we visualize this problem by drawing it, and we're going to look carefully because we know that over here, this forms a right triangle where this keeps increasing and this keeps increasing. Let's call this X, Y, and C. So because they never move outwards, X will never change. So we know that dx over dt will be equal to 0. But here, Y will change if the woman walks and if the man walks. So dy over dt is equal to 5 feet per second plus 4 feet per second, which is equal to 9 feet per second. Okay, now that we have these, here we want to find C, right? Because C is what we're trying to see. We're trying to see at what rate are the people moving apart, which is this side of the triangle. And we're going to, we know that C squared is equal to x squared plus y squared. C is equal to the root of all this, which is just equal to 1/2. Wait, what the fuck am I doing? X squared plus y squared to the 1/2. So C prime, we bring it down as 1/2 to x squared plus y squared to the negative 1/2 times 2x dx plus 2y over dt, sorry, because they're functions of time, dy over dt. So this is our basis, but we don't use that yet because the question asks us, or it tells us that 5 minutes later a woman starts walking south, so we need to know the distance that the man has already covered. So 5 minutes is 5 times 60, which is equal to 300 seconds. And then we plug it in for the man. So man, he's walking at 4 feet, right? Yep, 4 times 300. So he's already 1,200 feet. The people moving apart 15 minutes, so we need to find the distance that they've covered in 15 minutes. And that's 15 times 60. I have no idea what that is. Just search it up. Okay, so it's 900 seconds. And then we do man and woman. We do 900 times 4. And then 900 times 5. And we add these together. We get 2,600 plus 4,500. I have no idea what that is. That's why we have Desmos. Shout out Desmos for the sponsor. Plus 900 times 5. We have 8,100. So if we add all of these together, we're gonna have that y already is equal to 8,100 feet plus 1,200 feet is equal to 9,300 feet. And we know that x never changes, and that x is 500 feet because it's 500 feet from our initial point. So these are our dimensions for the right triangle. And now all we do is we plug it in, and we'll find the rate of change of c at the 15-minute mark. So if we plug all of this in, let's try it on Desmos. So we have 1/2 of, in this case 0, y is 9,300 squared to the negative 1/2. So here, we know that x will never change because they never move outwards. So it's 0, and therefore we can cancel this part of our formula and just plug in the 2y over dt. So 2y is 2 times 9,300, and the change is 9 feet per second. So this is equal to 9 feet per second. And that is the rate at which the people are moving apart at the 15-minute mark.